Okay, so we're going to have a look at some more questions from the 2024 Advanced Maths paper. We'll pick up with question 6. So what is the domain? So we're given this function, it is 1 over square root of x squared minus 1. Main conditions on this, the denominator can't be 0, and the thing inside the square root in the denominator cannot be negative. So we could summarize this by saying that x squared minus 1 must be greater than 0. Can't be equal to 0 because it would set the denominator 0, and that's not allowed. Can't be negative because that's not allowed by the square root. So we just need to solve this. So add 1 to both sides. We need x squared to be greater than 1. Square root both sides. We get x has to be greater than plus minus 1. Now, the minus is a little funny here. This actually manifests in an unusual way where this answer becomes x is greater than 1 and x is less than negative 1. Now, this makes sense because if x is 1 or minus 1, the denominator becomes 0. If it's between them, the thing under the square root becomes negative. Both of those things are not allowed. So the answer must be D. All values from minus infinity to minus 1, and then all values from 1 up to infinity, excluding minus 1 and 1. So question 6 is D. Now, question 7. We're given a function and then we're asked roughly what does its transformation look like once it's transformed in a particular way. Well, we are starting with some function f of x and we are transforming it to some function f of bracket 2 times x minus 1/2. So this is just factorizing. So we have a 2 times translation and a 1/2. Sorry, we have a 2 times modification, contraction or expansion, and we have a 1/2 translation. So it gets shrunk in by 2 times, and then it gets shifted by a half. So if we're doing this with theory of functions, you can apply those transforms. You can say, well, what happens if it gets shrunk in by 50%? So the intersections go from being 0, 2, and 4 to being 0, 1, and 2. Then you can shift it. And that's what we're going to do. So we start with our function. It looks like this, goes up here, goes down here, goes up here. This is 2, this is 4. We're going to apply the 2 first. So this is going to shift the whole thing in. So this intersection is going to be 1, this intersection is going to be 2. So it's going to have the same height. It's going to go up like this, go down like this, and then go down, and then come back up. So this transformed function has been contracted inwards. It's been squished inwards. And then it needs to be shifted. So now that it's been squished, it's got to be shifted. A minus, x minus, feels like it's to the left. Actually, it's to the right. So the whole thing is going to be shifted to the right. So this intersection will be at 1.5. The intersection will be 2.5. This one will be half. So we'll do this I'll do this as a green text to color so we can see it clearly. Down like this, up like this. This is what we expect our transform function to look like. Now, of the graphs, there's only one that has these exact intersections, and that's C. So the answer must be C. If you wanted to do a question like this perfectly, you'd need to know what the function was, and then you'd actually need to transform the function. Here, we're just getting an approximation of the transformation. All right, question 8. So for question 8, we're given a box plot, and then we're asked which histogram's not possible. Well, if we draw the little box plot, it sort of looks like this if we exaggerate it a little bit. 25% in the middle are much more spread out than the 25% on the outside. This box and whisker is 25% between each of the vertical marks. So we need a histogram that has the majority of its scores in the middle. Because if the majority of the scores are in the middle, then its box and whisker plot will not look like this. Now, the one for which that is most true is D. D has a lot of its scores lumped in the middle. And so D is not possible. It's not possible for D to produce a box and whisker plot that looks as the one does at the start of the question. So question 8 was D. Now, many people have said in this test paper that question 10 is the hardest one from multiple choice, usually the case. This one is as well. Question 9's wording is really weird. So we're going to be a little careful. It's very easy to read this question as something else. Bag contains 2 red, 3 white marbles. Joven selects 2 marbles, and then you're given a probability tree. Given that one of the marbles is red, what's the probability the other is also red? Okay, very strange wording. You could read it as saying, if one was red by default, what's the probability the other one is red? If that's the case, the answer is 1/4. You could also read it as, what is the probability they're both red? That would be 1/10. So these are answers a lot of students will give. This is actually a probability theory question, though. This is an A given B situation because we are asked, given that one of the marbles is red, what is the probability that the other is red? So you've got to read the wording there. The given tells us that this is actually probability theory. So P of A bar B is P of A intersection B over P of B. In this case, A is the probability that both are red, and B is the probability that one is red. So P of A intersection B is the probability they're both red. Well, that's just red and red. So 2 on 5 times 1 on 4. 2 on 5 times 1 on 4. Probability B, the probability that one of them is red, is red and then white or white and then red. So that's 2 on 5 times 3 on 4 plus 3 on 5 times 2 on 4. So this gives us 2 on 20 over 6 on 20 plus 6 on 20. That's 2 times 3 is 6, 6 plus 6. So this will give me 12. And we also need to include the double red in the PP. Sorry, we've got to include the double red because the probability 1 is red. That includes the probability that they're both red. So this will be plus 2 on 5 times 1 on 4. So this will be 2 on 20 over, we've got 6 plus 6 is 12, 13, 14, 14 on 20. This gives us 2 on 14, which is 1 on 7. So therefore the answer is B, which is 1 on 7. And it's very easy to mistake that question for something else. It's very easy when you're reading a question like that to assume that what they're asking you is a simple probability, when in fact, this is a given probability. It's a probability theory probability, not just a simple one. Very, very common mistake. Lots of students will lose that mark. All right, last question in this set. We're given a diagram. It gives us some function. Point Q is a point of inflection. We're told some other function, A, is the integral function of this one. And we're asked how many flexible points or points of inflection does the integral function have? Okay, well, I'm going to start this by just doodling down roughly what this function looks like. Curves, goes up, gets to a point of inflection, goes up again, curves, goes down, and then goes back up. So this is what we have. We're told a of x is the integral function of this function. So it's the integral from 0 to x of the function. That means this is actually a's derivative, approximately speaking. So based on the fact that this is a's derivative, we want to try and draw something that might look like the a function and work out, based on our drawing of the a function, how many points of inflection it has. This is going to be our strategy. So first, we're going to look for points where the derivative function is 0. 0 here, it's 0 here, and it's 0 here, and it's 0 here. So these are going to be minimums or maximums. So now we need to plot a series of minimums or maximums based on this. And they could be local or global minimums or maximums. Or they could be artifacts of the graph. So if the derivative is if the derivative is positive and then negative, that means this first point should be a maximum. So let's put it up here because the slope would be like this. So its tangent would be positive, then negative on the other side. This next point, we have the derivative is negative and then positive. So if it's negative and then positive, that means it should be a minimum of some variety. So we'll put this down here. We'll imagine this one looks like this. This one looks like this. This one here has a positive tangent leading to it and a negative tangent going away. So it is also a maximum. And then this one is also a minimum. So we have some function. It does this. Then it connects to this. This one connects to this. And this one connects over here. Now we'll assume this one just sort of trails off this way. It doesn't really matter what this minimum does, but we'll assume these sort of connect like so. If we think about these two functions, these have to connect sort of like this, and these have to connect sort of like this. Now, there may be inflections between these. So this is the function a of x. Now, we want to work out how many inflections it has. Well, in order to get the inflections, we know inflections happen when a double prime of x is equal to 0. So now we want to draw the derivative function of the a prime. We sort of know what our original function a of x now looks like, so we know where our candidate inflections are. Now we want to work out where a double prime is equal to 0. Well, the points where the tangents for a prime are 0 are here. This is flat. Here, this is flat. Here, this is flat. And here, this is flat as well. So these are the points where the a double prime function is equal to 0. So here, 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 and here. Now, if we look at the function itself, 3 of these points occur on the original function in sections which connect between maximas and minimas. So what we should have is an inflection here, an inflection here, an inflection here. The other one does not. This one actually occurs at a minimum. So even though a double prime of x equals 0 at this point, it doesn't create an inflection in the integral function. It's actually just a minimum. And that's just an artifact of the mathematics. So when we're looking at how many points of inflection the integral function, the ax function should have, it should have 3. So we should have 3 inflections. So the answer will be B. And this is the correct answer. It does have 3 inflections. So this was question 6 through 10 of the 2024 Advanced Maths paper.